This lesson is over quadratic applications. Example 1. At 630 feet, the Gateway Arch in St. Louis is the tallest man-made monument in the United States. Using the equation S equals 16t squared, where S is the distance in feet and t is the time in seconds, how long would it take an object dropped from the top to reach the ground? Round to 3 decimal places. Now, if you don't know the Gateway Arch, here's what it looks like. Now, they gave us some information, and since we have the picture or a diagram, let's label it. The arch is how tall? Well, notice it says at 630 feet, so we label it. Now, it says how long would it take an object dropped from the top to reach the ground? So let's better understand this. Imagine an object at the top of the Gateway Arch. We're trying to find out how long will it take for that object to fall and hit the ground. So now that we understand it, now let's see, what are we trying to find? Well, we're trying to find the time it takes to reach the ground. So for time, I'm going to represent it with the letter T. Now, so we have our define, we're ready for our equation. Did they give us an equation? Yes, they said S equals 16t squared. So there's our plan, but let's plug in any information they gave us. S is the distance. Do we know the distance traveled by this object? Yes, it's 630 feet. Now we keep the equal sign, and we keep the 16 since that's part of the formula. Do we know what t represents? Well, t is the time, and that's what we're looking for, so the t remains. So our equation is 630 equals 16t squared. Now that we have a plan, we're ready to solve. In this case, we're trying to solve for t. Now notice, this is a quadratic, but I only see t squared. I don't see any plain t's, which means I need to isolate my one and only variable. To help isolate it, I need to divide both the left side and the right side by 16. And so when I do that, we get the t squared by itself, but take a moment now to use a calculator and divide 630 by 16. Hopefully you found 39.375. So we've isolated t squared, but we're not asked to solve for t squared, we're asked to solve for t. So how do you undo squaring something? Well, you take the square root. As long as what you do to one side, you must do to the other. But don't forget about the plus or minus. Now, take a moment now to find the square root of 39.375. Hopefully you found t equals 6.275. And again, we have the plus or minus version. Now, remember, t stands for time. That means we have a positive time and a negative time. Are they both possible? No, we cannot have a negative time, so we mark out the negative option, which means t can only equal 6.275. Since we have our solution, we're ready for our sentence. It will take 6.275 seconds for any object to hit the ground. Now let's talk about the compound interest formula. This is represented by A equals P, parentheses, 1 plus R over N, close parentheses, raised to the power of N times T. Now this formula has quite a few variables, so let's make sure we know what they all represent. First, we start with A. That represents your ending amount. P represents your principal. R represents your interest rate. Specifically, it has to be in decimal form. You cannot keep it with a percent sign. N represents the number of times it's compounded, and T represents time. Now, all of these are pretty straightforward except for N. N is the only one that will be disguised as a word. So, N could appear as these particular words, as compounding periods. You may see the word annually, semi-annually, quarterly, monthly, weekly, and daily. Each of these words represents a particular value. Annually represents the number 1. Semi-annually represents 2. Quarterly, 4. Monthly, 12. Weekly, 52. And daily would be 365. So whenever you see one of these words, in its place, you would use the corresponding number. Let's look at an example. Example 2. Find the rate at which $15,000 compounded annually grows to $16,224 in 2 years. So first, we need to identify what are we trying to find. Well, notice the phrase, find the rate. Since we're trying to find the rate, let's use the letter R to indicate the interest rate. Now we have to write our equation, or come up with a plan. Notice the phrase compounded annually. That's giving you a clue that you are going to use the compound interest formula, which is of the form A equals P, parentheses, 1 plus R over N, close parentheses, raised to the power of N times T. So now that we know what equation we're going to be using, now it's time to plug in the appropriate information. Starting from left to right. First, we see the A. That means the ending amount after a certain amount of time. Do we know that? Yes, we know that in the end, there will be $16,224. Now, P stands for principal, meaning the beginning amount. Do we know that? Yes, that's the $15,000. Next, we do the part in the parentheses, 1 plus, and then some fraction of R over N. Well, R means our interest rate. Do we know that? No, that's what we're looking for, so we keep the letter R. Now we need to find N. Now remember, N is disguised as a word, so you have to go and find that particular word. Notice it says compounded annually. Well, how many times are things happening in a year if it's annual? Well, that's 1, which means a 1 takes the place. Now we're looking in the exponent. We have N times T. N, again, is that hidden word of annually. So we have 1 times. And now T stands for time. Do we know how long the money was in the account for? It was in there for 2 years, so now we replace T with a 2. This is our equation. Now we have to follow gems, and so first we are drawn to inside the parentheses. We have 1 plus R over 1. Well, R over 1 can be reduced, and also looking at the exponent 1 times 2. So when we clean this up, we then have the equation 16,224 equals 15,000 parentheses 1 plus R, close parentheses, raised to the power of 2. Now this is our equation. We're on a mission to solve for R, but notice R is trapped inside the parentheses. So to slowly solve for R, we need to remove the outside pieces. Since the 15,000 is outside the parentheses, I need to get rid of it. Since it's currently touching the parentheses, that means it's multiplying. So to undo multiplication, we will need to divide the right side and the left side by 15,000. When you divide the right side by 15,000, that will leave you with 1 plus R quantity squared, And on the left side, you will need to use a calculator to divide 16,224 by 15,000. When you do, you should find 1.0816. Now notice r is still trapped inside the parentheses, which means we need to undo squaring something. And to do that, we must use the square root. As long as what you do to one side, you must do to the other side, but don't forget about the plus or minus. So the square root and the square undo each other, giving you 1 plus r on the right side. But on the left side, you will need to find the square root of 1.0816 using a calculator. When you do, you should find 1.04. Now we're really close to isolating r. To get r completely by itself, we will need to subtract the 1, but it needs to go in front of the plus or minus. So when we rewrite it, it becomes -1 plus or minus 1.04 equals r. Since we have the plus or minus, we will need to create two different equations. We will have the -1 plus 1.04 equals r, and we will have -1 minus -1.04 equals r. From here, now we're ready to solve the two possibilities. Starting on the left one, we combine our like terms, and we find 0.04 equals r. Now this is the decimal form. Remember, we're trying to find interest rate, so if possible, we change this to a percentage. And when we do, we find that r equals 4%. For the second equation, I combine my like terms, which gives me -2.04 equals r. But notice, we have a negative sign. You cannot have a negative rate, so we throw away that solution, which means r equals 4%. Since we have the solution, we're ready for our sentence. The interest rate was 4%. Example 3. A stone is thrown directly upward from a height of 30 feet with an initial velocity of 60 feet per second. The height of the stone in feet t seconds after it has been thrown is given by the function s of t equals -16t squared plus 60t plus 30. Determine the time at which the stone reaches its maximum height and find the maximum height. Now let's make sure we understand the situation. Imagine there's a person with a stone in their hand and they throw the stone upwards. Everybody have a better idea now? Okay, now let's see, what are we trying to find? Determine the time at which the stone reaches its max height. Okay, so what are we looking for? Well, we're looking for the time it takes to reach its max height. Let's look at that again. If you throw a stone upwards, we all know what goes up must come down. What shape is that? Well, it's a parabola. And since we're trying to find the time at which the stone reaches its max height, well, that means what are we really looking for? Well, what we're really looking for is we're trying to find the vertex. When you throw something up and it comes back down, it does make a parabola. The max height is where it changes directions, which means we're trying to find the vertex. Now, vertex is represented by HK, but it's also an ordered pair, which we commonly know as x, y. But this time, I want you to look at your function. Did they give us a function in this situation? They did. Now notice, did they use the letters x and y? No. Instead of an x, what variable is inside the function? Well, that would be the t. And instead of a y, what do they have written? Well, they have s of t, which means we need to make sure we understand what these two represent. T stands for time, s of t stands for height. So we are looking for the time and height. Time would be your h or x value. Height would be your k or y value. Now we know we are looking for time of max height, and we're looking for the max height. So we haven't completed this problem until we have found both of those values. Now again, the phrase maximum means we're looking for the vertex. To find the vertex, we remember h equals negative b over 2a. Well, we have it set up. Our h value is now represented by t. And now we need to plug in our b and our a values. We get those from the function. So in the numerator, it's negative b. Our b value is 60. In the bottom, it's 2 times a. What is our a value? Negative 16. So now we have negative 60 over 2 times negative 16. We clean that up, and we find t equals negative 60 over negative 32. From here, we use a calculator to do the division, and we find t equals 1.875. So notice we defined t as the time it takes. We have the equation. We've now solved it, which means I can now say the time of the max height is 1.875 seconds. But the last thing is I do need to write a sentence. It can be short and sweet, such as, it will take 1.875 seconds to reach the max height. Now that we have the time, we're ready to find the max height. In order to do that, we must plug our found value of time, 1.875, into the original function. Now, that means every time you see t, we now replace it with the value of 1.875. From here, we have s of 1.875 equals negative 16 times 1.875 squared plus 60 times 1.875 plus 30. Once it's plugged in and it's written on your paper, now you may pick up a calculator to find the result. Hopefully you found the result to be 86.25, which means at the time of 1.875 seconds, the maximum height will be reached at 86.25 feet. And so the last thing is we do want to summarize this, and we write our sentence. The stone will reach a max height of 86.25 feet. A company has found that the revenue from sales of a set of tires is a function of the unit price P that it charges. If the revenue, R, is represented by R of P equals negative 0.1 P squared plus 55P, then A, what unit price should be charged to maximize revenue? B, what is the max revenue? Well, this is your try it problem. But I will give you a hint. Notice the word maximize. Anytime you see maximize, it's telling you you need to find the vertex. Let's see how you did. Hopefully, you identified you must find the unit price and the max revenue. You should have defined P as the unit price, and to find the vertex, it's negative B over 2A. Your B value was 55, your A was negative 0.1. You plug those in, you should have found P equals 275. Then from there to find the max revenue, you must plug in 275 into the original function, and when you do, the result should be 7,562.5, which means the company should charge $275 for the unit price, and the max revenue would be $7,562.50. Example 4. A homeowner wants to fence a rectangular play yard using 80 feet of fencing. The side of the house will be used as one side of the rectangle. Find the dimensions for which the area is maximized. Find the max area. Now, I suggest you draw a picture. So I have the wall that represents the house, and I'm going to create a rectangular play yard. Now, we have the shape of it, but we need to label it. Notice we have a width, we have a length, and we have a width. There's only 3 sides to use the fencing because the house is providing one side of the rectangle. Now, notice it says we have 80 feet of fencing. That means together I have the width plus the length equals 80. The problem is we cannot have 2 variables floating around. We cannot keep a W and an L. So, looking at our equation, is there a way to rewrite the letter L? And there is. If you look at your equation, I have W plus W, which can combine to give you 2W plus L equals 80. Well, if I want to rewrite in terms of L, it means I need to get L by itself. So I subtract 2W on both sides. And I find the length, L, can be represented as 80 minus 2 times W. So on my figure where I drew the rectangle, I will replace the L with 80 minus 2W. Notice all 4 sides now are using the same letter. Alright, now let's look at the problem. It says, find the dimensions for which the area is maximized. When it says dimensions, it means we're being asked to find the width and the length. Also, it says, find the max area, which means we're also trying to find that. So this problem, we have to find 3 specific things. Well, let's get started. First, we will need to define our variable. In this case, since we have W, we will define it as W equals the width of the play yard. Next, we need to come up with a plan. Notice it says find the max area. Well, this is the area of what shape? A rectangle. So to find the area of a rectangle is width times length. So in this case, we're going to plug in the information that we have. So our area represented as area dependent upon W, so A of W, equals, now width. What are we using to represent width? Well, look at the figure. We have a W. Next, how are we representing length? Well, the figure, we have 80 minus 2W. Now we want to kind of clean this up. We have W times 80 minus 2W, so we need to distribute. When you distribute, we now get 80W minus 2W squared. Because we have W squared, this is a quadratic, but we need it to be in the correct order. So when you rearrange the terms, you now have A of W equals negative 2W squared plus 80W. Now we have our equation. Now, to identify the dimensions that maximize this, because it says maximum, that's giving you a clue that you have to find the vertex. Okay, maximum is a vertex. In this case, we're not using H and K. This time, our variables are W and A of W, which means we need to find the width, the H value. Well, of the vertex, H is represented by negative B over 2A. Well, look at our function. Our B value is the coefficient of W, which is 80. Our A is our coefficient of the W squared, which in this case is negative 2. So we clean up this fraction and we have negative 80 over negative 4. which we know divides to give us W equals 20. Well, what does that mean that W equals 20? Well, that means we just found the width. The width is 20 feet. Now go back to your figure. The side that has a W, you can now call that 20 feet. In the other side that has a W, you too can label that 20 feet. But what about the length? Can you figure out the length? Yes, because 80 minus 2W, well, since we know W, we can now plug in a 20 for that. And when we simplify that, we find the length to equal what? 40 feet. So we have now found the dimensions of this play yard, but we still haven't quite found the max area. Well, remember, the area of a rectangle is the width times the length. Do we know the width? Yes. Do we know the length? Yes. So the area equals 20 feet times 40 feet. And when you multiply, you will find the area equals 800 square feet, which means we have found the max area. Since we have found all the solutions, now we want to summarize and write our sentence. The play yard would be 20 feet by 40 feet and would have a max area of 800 square feet. Example 5. A farmer needs to separate and enclose two adjacent rectangular fields, one for blueberries and one for strawberries. A lake forms one side of the field and 240 yards of fencing is available. So what is the largest total area that can be enclosed? First, let's draw a picture. We have a lake on one side, and then we have the fence. But it's two fields that are side by side. Again, one's for strawberries, one's for blueberries. Now, if I want to label this, I see I have a width, and a width, but the other side is the length. Is there another way to represent length? Well, let's look at the information we do have. We know that if we were to add all the sides or all the fencing, that would be the width plus the width plus the width plus this length would give us 240 yards. Now, if I simplify that, that gives me 3W plus L equals 240. Well, I want to rewrite the length in terms of width. So let's get L by itself. To do that, I subtract 3W on both sides, which means the length is the same thing as 240 minus 3W. So in my figure, instead of putting L, I put 240 minus 3W. Now look at your diagram. We have W's all over the place, but nowhere have we defined it. What does the W represent? Well, it represents the width of the field. And so this is our official define. Now that we have a better idea of the scenario, let's see what they're asking us to find. Notice it says, what is the largest total area that can be enclosed? Well, it says total area, which means we're finding the area of this figure. Altogether, what shape is this? Well, it's a rectangle, and to find the area of a rectangle is length times width. And so the area is dependent upon our variable, which means it is A of W. Now look at your figure. What did we call the length? Well, we called it 240 minus 3W. What did we call the width? We called that W. And so now we need to multiply our length times the width, which means for us, we will need to distribute, which gives us 240W minus 3W squared. Since we have W squared, that means this is a quadratic, and so it needs to be in the correct order. If we rearrange it, we will now see A of W equals negative 3W squared plus 240W. Now this is our equation. Again, we go back. What are we trying to solve for? Notice it says, what is the largest? Anytime you get the word largest, maximum or minimum, that is code for something. It's telling you you need to find the vertex. So because of the word largest, we're looking for the vertex. To find the vertex, it's negative b over 2a. We'll look at our function. Our b value is 240. Our a value is negative 3. And so when we simplify this, we find negative 240 divided by negative 6, which together gives us w equals 40. Now this doesn't ask for the dimensions, it says what is the largest total area? Well, what does our function represent? Our function represents the area. So our function of negative 3w squared plus 240w tells you the max area. The good news is we now know what w represents. It represents 40. So every time you see w, we plug in a 40. From here we follow gems. We do the exponent first, and then we do the multiplication, and in the end we find that the area is 4,800. So since we have answered the question, we're now ready to write our sentence. The largest total area enclosed would be 4,800 square yards.